Okay, this podcast is going to talk about how to do a t-test on SPSS. Now, t-test is a test that you use when you want to compare two means. And normally, you're doing that because you have done some kind of experiment and you've manipulated your independent variable by normally having some kind of intervention and or manipulation and some kind of control group, and you want to compare the two. Now, you can do that in one of two ways. You can either do it using different people, so you have two groups of people that you're trying to compare, or you can do it as a repeated measures design where you use the same people but you measure them at 2 points in time. So there are two types of t-test. One is an independent t-test, and that's the one you use when you've got two groups of people or two independent sets of data effectively. And the dependent t-test, or sometimes called the matched pairs t-test, is when you've used the same participants, or you've basically got related data. So you've got data from two conditions that kind of come from the same source, whether that's a human or a frog, an alien, who knows. Now, the example in the book is looking at spider phobia. And I chose this example because I'm pretty terrified of spiders. And in psychology, if you want to treat a fear of something, one of the ways you can do it is by getting the person who has the fear to associate the thing that they're scared of with something that they find pleasurable. So normally it's kind of relaxation. But in my case, I wanted to confront my fear of phobias by pairing it with the most pleasurable activity in the universe, which is analysing data. So I thought this was kind of a good example to choose because I could confront my fear at the same time as telling you how to do a t-test. So it's all about spiders, these little things. Ooh, scary. Well, not really. Not that scary, but a bit scary. Anyway, what I was interested in is whether people's anxiety about spiders would be influenced by whether the spider was a picture of a spider or whether it was a real spider. Now, what you'd expect is if people are confronted by a real spider, then they should be more scared than if they're confronted with a picture. So in the book, we've got two sets of data. Actually, it's the same set of data, but organised in different ways. And this is just to illustrate how to do the test if you've got two groups of data versus if you've got two sets of data that are related to each other. So first of all, we'll have a look at the data set that deals with two different groups. So if you look in the data view of the SPSS data editor, you can see how the data are laid out. Now, essentially, we've got a bunch of anxiety scores in this column here. We've got a grouping variable. So this is a variable that tells SPSS to which group a person belonged. So, as is usually the case, each row in the data editor represents a person. So this first row, for example, is person 1. They were in the picture condition and they had an anxiety score of 30. If we move down here, this is a different person, person 13. They confronted a real spider and they had an anxiety score of 40. Now, this grouping variable is if you look at the podcast on how to enter data, it's all covered there, but essentially we've got a bunch of zeros and ones. So 0 means you had the picture of the spider and 1 means you had the real spider. If you use this button up here, you can toggle between the numbers and the words. So in the variable view, this variable group is simply set up as a numeric variable where we've entered some value labels. So a 0 means picture, a 1 means a real spider. And we've made sure that SPSS knows that that's a nominal variable. So data look like that. Now, if we compare this to if we tested the same people under two conditions, so at one point in time, we'd shown them a picture of a spider, measured how anxious they were, and then at another point in time, we'd shown them a real spider and measured how anxious they were, then the data will be laid out quite differently. So I've got a different SPSS data editor here with the repeated measures data in. You can see in this case, again, each row represents a person, but this time the person has taken part in two different experimental conditions. So we have two bits of data for them. First bit of data will be their anxiety score when they saw the picture, and the second bit of data in a different column will be the score or the anxiety score that they had when they confronted the real spider. So here, participant 1, when they saw the picture, their anxiety score was 30, but when they saw the real spider, their anxiety score was 40. So the data are laid out differently if you have a case, if the two conditions you're trying to compare have independent data or data that come from the same source. So how do we do the t-test? Well, let's go back to our between group data. So we're looking at a situation where we've got one set of data which relates to people who saw the picture of the spider, and a second group of data which is people who saw a real spider. Now the t-test is in the Analyze menu. That's where everything is pretty much. Well, everything to do with data analysis. So we want to compare means, and you can see if we go to the compare means menu, we've got several options, and one of them is the independent samples t-test. So when you've got two different groups of people or independent data, we want to use the independent samples t-test. So if you select that, you get a dialog box like this, and it's pretty straightforward. SPSS asks you for a test variable. You can list several variables here if you want. This is basically your outcome, and in our case our outcome is anxiety, so you can select that and drag it over there. And it also asks you for a grouping variable, so this is the variable that defines the two groups of people. In our case it's whether it was a real spider or a picture, so you can drag that over to the grouping variable box. It then asks us to define the groups. Now you notice at the moment group appears with 2 question marks after it, and SPSS is basically saying, "Ooh, I don't know which numbers represent which groups, can you please tell me?" So you click on define groups and you specify the values. So group 1 we know was specified with a 0, whereas group 2 was specified with a 1. And just click on continue. And then in the options, if you want to go there's basically nothing particularly interesting to change. But if we want to change the confidence interval to be, say, 99% or 90% or whatever you fancy, you can change that there. But I'm going to leave it as 95 because that's typically what people use. Click on OK to run the analysis. And in the output window, you get some reasonably straightforward analysis here. So we first of all have some means. So in the picture condition, the mean there were 12 people, and the mean anxiety was 40, and this tells us standard deviation, standard error, etc, etc, etc. And in the real spider condition, there were again 12 people, and there was a mean of 47. So this is useful for interpretation because it tells us that the mean in the real spider condition was higher than the mean in the picture condition. Now the question we're interested in is that difference significant? Now to answer that question, we look down here at the table below, and essentially first of all there's a test of whether the variances across the two groups are equal, which is known as the assumption of homogeneity of variance, and we need to check that. And basically if this Levine's test here, so this is a test statistic 0.78 and its significance level is 0.39, and that's not significant. Because the significance is bigger than 0.05, we can conclude that the variances across those two groups are not particularly different. So that's good, it means the assumption is met. And but even if it wasn't met, it's not too much of a problem because SPSS produces down here some adjusted values. So if you can't assume equal variances, you just look at this bottom row here. But we're going to ignore the bottom row because our variances are equal, and we're very happy, and we're going to put on a little party hat and have a dance. So are the means the same or are they different? Well, we get a t statistic here. This is our test statistic, which is minus 1.68. Degrees of freedom associated with it, and the thing we're mainly interested in terms of trying to determine whether the means are significantly different is this value here, so the significance. Again, typically we use 0.05 as a probability to determine significance. So because this is bigger than that value, it means that there is not a statistically significant difference between those two groups. In other words, there's no statistically significant difference in anxiety levels depending on whether you saw a real spider or a picture of a spider. And this is also borne out by the confidence interval, which you can see here crosses 0, which means not significant. Okay, so that's all well and good. Now, let's say we'd collected these data as a repeated measures design. So rather than having two different groups, we just had 12 participants, the same 12, and we showed them a picture of a spider and a real spider at different points in time and measured their anxiety. We do the t-test slightly differently in this situation. Again, it's in the Analyze menu. Again, we want compare means, but this time we want a paired samples t-test, which is also known as a dependent t-test. This gives us a slightly different dialog box, as you can see, and essentially it wants you to pair up variables. So it wants to know what the columns in the data editor are that represent the two different experimental conditions. Now the spreadsheet we've got is actually pretty straightforward because there's only two variables in it, but you might have lots more variables, so it's just a matter of picking the columns in the data editor that represent the two conditions that you want to compare. So we want to compare a picture of a spider, so we drag that into variable 1, and we want to compare the real spider condition, so we can drag that into variable 2. So we've now created a pair. Now notice that the minute you've created a pair, SPSS allows you to select a different pair, so you can run lots and lots of dependent t-tests at the same time if you want to, and it will just keep adding pairs down here as you kind of specify them, really. Useful thing to know, actually, potentially, is if we get rid of these, you can select two variables at the same time. So if you click on one variable and hold down the control key on a PC or the Apple key on a Mac, you can select two things at once and transfer them across at the same time, like so. So rather than dragging individually, you can select two things and use this arrow and they'll both go across at the same time, which can sometimes save a bit of time. In the options, same as before, we can adjust the confidence interval if we like, but I'm not going to do so. Click on OK, and again in our output window we have a t-test. Now it's slightly different from before. Now the first thing is, again, we get this table of means and it's exactly the same as before. So the mean in the pitch condition is 40, but in the real spider condition is 47. That's because the data are exactly the same. However, because our data are related, they come from the same people in this case, it also gives us a correlation between those scores. So the correlation between scores in this example is 0.54, which is actually reasonably high. The main thing again though is this is the table that gives us the actual t-test. Now when we have a repeated measures design, we don't have to worry about homogeneity of variance. That assumption doesn't apply anymore, so we just get one set of results here, and the t-test is now minus 2.47. Its confidence interval down here no longer crosses 0, so that kind of indicates a significant t. Degrees of freedom are 11, and you can see the significance now is actually less than when we analysed it as a independent design. So the p-value is now 0.031. This is less than our critical value of 0.05. So we would say there's a significant difference between the two groups. And looking at our means, what it tells us is that when people saw a real spider, they were significantly more anxious than when they saw a picture of a spider. Now, the reason I've used the same data set, but changed whether it's treated as an independent design or a repeated measures design, is just to show you that repeated measures designs are typically slightly more sensitive, because a lot of the individual differences between people that you get when you have different people across groups is kind of wiped out. So it can be a more sensitive way to do things. So that is pretty much everything you need to know about the t-test, kind of, at any rate. And yes, Don't be scared of spiders. They're nice. They eat flies.